So that's what we're going to talk about today. Um, if anyone that knows me knows I don't do a lot of worded slides. I would rather just talk and show some images and give you resources for later. So that's most likely what I'm going to do right now. Um, yeah. So cool. So let me share the screen quick. Do this. Do this. Do this. Mm. Yeah. Can we all see my slide?
Yes, we can.
Perfect. I'll take us up to the top. Yeah, blockchain concept. So basically, I'll like us to we understand the the network, what blockchains are built on. That's very important. The next thing I'd like us to understand is what is a blockchain network in itself. So we can put in the chat box what we understand by blockchain currently. Though I'm definitely going to talk about it, but let's put in the chat box what we currently understand by blockchain, and then we'll see how we can build from there. What's a blockchain network? So basically, in summary, if you're looking for a definition, even though to be honest, there are so many definitions, right? But the basic summary of what a blockchain network is a shared immutable ledger of data that records transactions, that's activities, and it tracks assets also. And this data and this transaction being recorded and all these assets, they're all on a peer-to-peer network, right? I've talked about peer-to-peer network. Don't mind the big this thing. Shared is obviously shared. We understand what sharing data is from part of our discussion yesterday. How and even as Ebuka spoke about it, how everyone has a replicated database of all the information on the blockchain, right? This is what makes it immutable. So this is what makes it is hard to delete all the data, right? You have to delete every single every single pair on the network has to be destroyed before you can say that you have destroyed the data on the network. And so basically so it's shared and it's immutable. The data has been replicated, and the recording of transactions. So basically, transactions are um, um, movement of data on the blockchain, and a transaction is a recording of what is happening to that data. We'll definitely get into it in details in this class. And then also tracking assets. A lot of us know about NFTs and the rest. That's not our core for today, but I just wanted to put it there so that we have that as part of the definition. So there are five basic properties of a blockchain network. We all know how peer-to-peers are. Peer-to-peers are you can connect from one person to another person directly with just their information, with just their address or something, right? And you get access to their system. You can talk, you can gist. That's P2P, right? But that's obviously that is not all the the blockchain network is, and we will get to that. The goal of the blockchain network, why everyone why the blockchain is so a lot of people on the in the community refer to it as like the future of information. The goal of it is the beauty of it is number one, it stores data, it persists data, right, for a lot of people. Number two is transparent, right? Um, so maybe I should have written these characters or these. What I'm saying now is not necessarily a a feature of the blockchain, but it is what is expected of any blockchain network, right? The blockchain network is expected to have redundant. So the data should be there should be high redundancy. There should be openness of information. So because everybody has all the data, and it takes multiple people to validate whether data is should be added to the shared database or not, everybody can see all the transactions going on the blockchain network, right? Imagine you being able to see all the bank alerts, the bank transactions going in and out of your central bank in your country. I'm sure that would bust brains, right? A lot of countries will like destabilize. They were like, "What? You have such and such money?" But the blockchain, the reason why a lot of people love it and swear by it because of the transparency. Because since everybody has that data, who are you hiding? The only thing that people don't know is the owner of the wallet address. But everything that happens, like everything that happens on the network, they know this address sent this money to this address sent this money to this. If somebody stole 500 billion million, for example, there have been some hacks that you hear in the blockchain network, right? This genius person found a way into this, maybe let's say Binance, this trading platform, and maybe hacked something and then went out with money. They can hack it, the money can leave, but everybody, if you look at the trail of information on the blockchain, you know the address that removed the money. You know where they put money to. There are ways to obfuscate, to they now change it and they now try to mix it and share the money, which is kind of why you hear different hacks on the blockchain network, that some of the hackers try to return it or some people try to get them to return it. The reason why this is even possible is because everything is transparent. Everybody can see the malicious address, and they could still get away with it because some people do, but it's not as might not be as easy as you just, hey, let me take money from central bank and then just run. Do you understand? So yeah, that's a different conversation altogether. But we are talking about technically now when it comes to the functionality of blockchain networks. There are 5 key features that are needed, that are essential for every peer-to-peer network or blockchain network to claim that it's a network. Number one, they have to have a way of encrypting data. When you are sending data to a blockchain network, if you want to send a transaction, so the blockchain records, the blockchain can record, for example, you want to mint an NFT, you want to store your art, and it mints a token for you, and it says, oh, I'm the owner of this art. And because there are so many people connected to the blockchain network, you can say, okay, yes, this person is really the owner of this art, right? I wanted to see the questions or some definitions of blockchain, but there was none there. Please let me know if I'm going fast. Let me know if you're not understanding what I'm saying, right? Um, so yeah, back to my train of thought. So you have to have a way to encrypt data. Encrypting a transaction, I'm trying to differentiate a transaction and a token in the NFT space. When you are minting a token, any kind of token, NFT, whatever, that's a different topic. You are basically storing something on the blockchain. The blockchain is encrypting the key, the access to ownership of that thing, and telling every other person this is the owner, right, of that item. That's tokenizing something on the blockchain. But a transaction on a blockchain is typically the transfer of value from one address or one asset to another. Basically, you are basically sending it from one place to another. That is a typical transaction. A typical transaction can be, Ada has $50. Okay? Ada Success has $30. Ada is sending Success $10. So Ada now has a total of $40. Success now has a total of $40, right? This transaction, this movement of value of ETH, of currency, is typically what a transaction is, right? There can be, is the smallest form of a transaction, right? So when you are trying to say, oh, Ada wants to send Success money, what happens at that point? I can't just write in English and go to the cryptocurrency and say in English, Success, take. I have to know his address. We will get to wallet addresses soon. And that's basically a way to pinpoint him on the network and say, this is the person I want to have this value. And then I have to have my own address to show that I'm part of that network, and have to have a way to encrypt the data such that it is in a way that the network can understand, or that the players of the network can understand. Typically, an encryption for a network should not be able to be decrypted by another network. So if you have a block of data now on Ethereum now, and you maybe print out all the string, because some of us are developers, of the encryption codes and all of that, if we try to replicate the exact same thing, it should fail on Binance, or it should fail on Bitcoin, because they all have different individual encryption techniques, right? So that's the first thing. They have their way of encrypting their own data that fits with their network and is unique to their network. If you don't have access to public keys, if you have not created a wallet address, you don't have access to send any transaction to that network. Basically, they have a way of authenticating it, right? So every blockchain has encryption. Another thing that is a characteristic of every blockchain is consensus mechanism. What is consensus? The word itself, consensus, is, for example, we are all on this call, let's vote who has the nicest jams, who has the nicest taste in music. Everybody votes Zainab, right? She be dropping hits. Do you understand? If we are 20 people on this call, and 10 people and 15 people say Zainab is the bomb, and 5 people say that Zainab isn't the bomb, consensus says that she won. She has the best music. So that's basically what it is, right? Forget the words. Consensus is basically an agreement from all the nodes on the network that the data coming in is valid, right? And then there is mining. Mining, they have to have a way of people to, for example, I now, like I was saying, if I wanted to send money to Success, I can't come around English. I would find a way to encrypt it in a way that Ethereum blockchain will understand. I'll find a way to send to the P2P network such that a miner now, when they see that encryption, the person that will decrypt it, they'll look at the information like, this thing is cool. We have our address, because they have a lot of keys and Ethereum keys and algorithms that are associated with mining software. If you put it in your system, which is why a lot of it can be computer processing intensive or time intensive, because they have to decrypt, they have to find out this data coming, does it have virus, can it break other things? And then once they sees that it has mined it and it has said, oh, okay, this this transaction seems okay, it now broadcasts it to everybody. Like, guys, basically tosses it in the P2P, in the pool. Like, guys, this is a good transaction that I have mined, right? So these other guys now will now look at the transaction, and based on some other encryption algorithms that they do, they are not mining it, but they're checking the validity of it. Do you understand? Checking if it makes sense. The way that the miner has mined the whole process, the consensus guys will now confirm, like extra one or two checks, like, is it okay? Everybody in the network has to confirm if it's okay. At least most at least Ethereum, the merge has changed a couple of things, but I shall not digress. But basically, everybody confirms and sees that mined information, like, oh yeah, this looks nice, and then they add it, and then when it passes the consensus, it gets added to the immutable ledger, and then it is duplicated in every system in the same order, in the same way. One easy way to understand. So after there's consensus, right? Everyone basically has the same chain of data in the same order. So the one of the unique traits of a blockchain network also, which is what makes it pretty hard to delete data or to put in malicious data, is that each chain, for example, you are seeing 1, 2, 3 here, they all have the same data, right? Each for example, like number 2, each chain is built on the encryption of the first chain. So I did know this explanation might be a bit weird. So I went on some sites to look for like a demo of, and I'll post the site here. Me, I like practical. Anyone that knows me, again, don't know this about me. So this people, this site, they are basically trying to, I'll share what I'm doing in this window. This is the link to the site that I'm on. So you can get on it and just see what I'm doing. This is a real kind of world example of how the data in a blockchain network connect together. Please put questions if I'm going too fast or confusing everybody or anybody, right? Because I'm feeling like I might be talking fast. Please just put questions in there. So now I'm trying to share this blockchaindem.io, the website for the thing. Okay, I have a. Can you guys see my screen?
Yes, we can.
Okay, cool. So this blockchain demo basically. So how it generally works is there is usually a genesis block, the original block, the OG, the starter of the information, right? So usually a blockchain will start basically with, for example, Ethereum. They have a total number of ETH in circulation. It could be hundreds of millions, to be honest. But for our understanding, let's say maybe the network says we have only 100 ETH. This is all the money in circulation. So the Genesis network has that, has the money in circulation, has the measurement, it has all the initial data. It has, and then it has like the address of the very first person that is entering that initial data, right? So any data that you add to the network, it takes the hash of the previous block and then encrypts it to get a new block. So the first block is kind of an encryption of, and the second block is an encryption of something from the first block. Same, the third block is an encryption of the encryption of the second block. The fourth block is an encryption of the so if you get what I'm saying. So that's kind of the concept that brought the whole logic of blockchain, right? So if any data if any history of data is manipulated in any way, it affects the hash keys for the future chains. And then automatically your network, it throws a consensus error. Every other person in the network, guy, that's not how my own looks, or that's not how mine looks. You are a malicious person. You want to say, you want to collect, you want to lie that 50 ETH was sent to your account yesterday when only 5 ETH was sent to your account, right? That's basically the validation way that the network validates data, and so on and so on and so forth. So you can imagine a network as big as Ethereum, how much transactions and chains of blocks of data and transactions that are in there, which is why it's like you the only way to I want to say the only way to hack a blockchain network will not be to enter malicious data. It will be to trick smart contracts handling money, trick them to believe that the future transaction they should send you money. That's typically when you hear, oh, there is a hack. The hack was tricking an existing smart contract that have been plugged into the blockchain network to do some transactions. The hacker is tricking that contract to believe, oh, this is a good transaction, or you are the real owner of this money, and then they send you money. That's the only way to hack a blockchain network. You cannot backdate the data because of just the nature of how it is. So it is basically community culture that like everything is open, every transaction is open. So you can, in this blockchain demo thing as well, you can also add a pair. And then so I put this link on there for you guys to play around with it, and so that for me, like, visualizing concepts help. I hope it also helps you. I am gonna also go to Ethereum blockchain, etherscan.io. Again, Ethereum is not the only network. It's really not. There are a lot of networks, plenty. However, the one that is the because it's the first programmable blockchain, the first blockchain that says you can host a smart contract here and manipulate data. So individuals were allowed to host things there and manipulate data and transactions. Is one of is basically, correct me if I'm wrong, I think it's the first. So a lot of existing blockchains are built off of this protocol or of this entire, the way that Ethereum is built. Most blockchains are built off of it or built using it, but maybe tweaking a couple of things that make it look different, right? But generally, this is the oldest. So these are basically transactions that happen. This is 13 seconds ago. This is the block that was just added. These are the latest blocks. These are the latest transactions, right? So you can tell. So the transaction basically tells you this has been sent from here to here, how many ETH? From here to here, how many ETH? And the block basically container, right? I said, oh, in this block, there were 96 transactions and 30 contracts. So you can literally, that's how visible the blockchain network is, or at least most blockchain networks try to be. Again, Ethereum is not the only one. And then when you can go and see a list of every transaction, and then you can even see a list of smart contracts. What's a very popular smart contract? Why not? Yeah, so there are different. You obviously it's not every smart contract that you can search by the name on Ethereum on Etherscan, but the popular ones that a lot of traffic you can usually search by the name. They would usually add their website and add their name and their social just to provide some validity. Like we are the ones who you understand. Yeah. So this is a Binance token. This is a contract for the initialization of the token. Literally, if you wanted, you could copy and paste this entire code and mint your own Binance token. It's everything is public, right? So that's the main concept. This is just showing. We would um, just for your understanding. Let me get back to the presentation. Let me get back to the PowerPoint. But are we all following? I feel like it's so quiet. I'm not used to lecturing one way stream of classes. I'll try and wrap up early today so you can ask questions. I will share the thing again. So going back to the top, 5 things. He has a way to encrypt data. He has a way for everybody to agree that okay, this is the right data to add to our chain, or this person is not malicious. You know, like for example, someone wants to be a new miner or a miner wants to enter data. Like this data is not corrupting the former data. Do you get that kind of thing? Once the majority of the people on the network think that you are malicious, they can literally sanction you and kick you out. Um, as a miner, by the way, as a miner. So a miner is you are installing Ethereum software, you are validating data, you are validating blocks and adding blocks, right? However, as a normal citizen that has computer knowledge of smart contract and want to trick a smart contract into sending you money, technically they don't know who you are per se. So that's how people hack. Please don't go and hack. But anyway, that's how it is. So we have talked about encryption. Yes, so to talk more about encryption, because of how important encryption is to each network, right? You have to have a way to um, encapsulate like your data kind of, so that um, well, the most important reason for encryption, that's even the one that I missed, and that's the one that is very important, right? The most important reason for encryption is also for identification. So how many of us know kind of what the general concept of encryption? Can we write it down in our chat? What do we understand by encryption? When we hear public key, when we hear private key, I know some of us are developers, some of us know API keys, public keys, some of us know JWT keys and all the encryption keys. Just give me a brief understanding of what you know by those things, right? So when it comes to encryption, there are two major types. There is the symmetric encryption and there's asymmetric encryption, right? I didn't want to go into it in depth, so I'll just run through it first. Say, our next class is when we are really going to enter encryption in depth. And basically, we're going to enter Ethereum in depth. So you're basically going to understand a lot of how Ethereum encrypts and decrypts and the rest, right? But basically, the blockchain network uses asymmetric encryption. So is the to cut the long English short, it's just basically the encryption that makes it such that the owner of the data, the creator of the data, has a private key, and then the people that want to read the data, he can give them a public key to access the information. Right. So this concept might be familiar for some of you that know APIs and the rest. So it's a very similar thing that this, for example, if you want to register people that know APIs, you want to go to um, basically, if you want to share data between or share secrets, you can say, oh, there is a secret key and then there is a public key. You can share your public key with another system that can use that public key to access that your API, but your private key that you use to create it will always be, your own information. It's the same asymmetric encryption logic that is used for blockchain encryption. Obviously, um, asymmetric. Um, Obviously, there are different ways of encrypting and the rest. They are all asymmetric, meaning the creator has a private key, shares the public key. Only people with the public key can see the information. So, so before you access or before a blockchain network gives you access to their network, usually they would require you. In fact, I think everybody, to be honest, will require you to open a wallet for that network, right? A wallet is basically you are encrypting, you are creating an identity, right, for yourself. on that network by you have it. So usually when you're creating a blockchain wallet, they always tell you this is your private key. Never share your private keys. Usually a long string or something, collection of 12 to 24 words, I don't know. And then anytime you want to go to any system to recover that you are the owner, do you understand? From any system, you can sign into the blockchain network, and if you want to recover data, any data that that address has signed or has pushed forward, you can enter that private key, and then the network is like, okay, yeah, you are the one that did this, right? So it's just a means of identification for anybody that wants to participate on the network. It's also called EOA, is like an end user address based basically. So that wallet address is usually a string of 12 to something words characters, right? That address is the public key. So when if we went to, I have already closed my Etherscan. If we go to Etherscan and we see those transactions, any of you that are on, by the way, let me even post the link to the Etherscan on the channel as well, so that you guys can see what I was saying and play around with it if you want. It's okay not to get everything that you are reading for now, but to give you ammunition to ask questions next time we're having a class, right? But at least just looking at it and just seeing how things keep coming in, you know, then like honestly, I don't make a lot of sense, but you get the understanding that everything is open, everything is transparent. Yeah, so um where was I actually? I was talking about the public key. So your identification to perform any action on the blockchain network is usually a wallet address. So that address is an encryption, is an asymmetric encryption has that says who this person is. It really doesn't have a name or anything. They don't need your name or address. You only have to have the private key. Once you have the private key, to that encryption, it shows that you are the owner, which is why everybody will tell you it does not matter what any um, Bitcoin group tells you or crypto group tells you. Anybody that asks for your private key is a thief. They're a thief. They're a thief. If you give them your private key, and usually, especially for Ethereum now, I'm not sure every other blockchain network, but for Ethereum now, once you lose your private key, you cannot you cannot verify that you are the one that owns that wallet address. That's the information, the ethers owned by the address. Any information that is assigned to that address is lost to you forever. It exists on the network, but as long as if you cannot provide evidence that you are the owner, you can never access it. I know it's heartbreaking. So you guys keep your private key safe and never share with other people. So yeah, that's the entire concept of the network and how it works. Um, to interact, you have a wallet. The wallet contains is it's a wallet because it has the ability to contain data. So it has the ability to show that you own this person has some ethers, right? If you wanted to buy money into the Ethereum network, you would use a wallet address. You would say, this is who I am, right? And then you would go to Binance and you say, this is my wallet address. I want to buy this money. And when they send the money to Ethereum, they'll send it to that address. And unless you have the private key to access that network, you will never access that money, basically. So that is the general concept of what a blockchain network is and how it works. I'm trying my best to be as technical and not so technical as possible because we are developers. We are not. I'm not trying to be too abstract because we are supposed to understand how the details work. And I'm also not trying to be too far in front. So, yeah. In summary, that is a blockchain network. There are five elemental things. You have to be able to verify data and mine the data. There has to be a consensus. There has to be a hashing mechanism to identify who does what. To the hashing mechanism is also a unique signature to the network, right? It's unique to the network. It's unique to the individual, and it's the only thing that identifies who does what. And then the ledger is immutable. Any future block you want to add to the previous blocks, if you try to damage, or if you try to change any other blocks, every single thing in the future is and every single thing is going to react, because every encryption of the block as it's stored based off of the previous block. So if you try to tamper with any previous data, everything in the future is going to tell you, guy, no. And then the consensus, the entire pair peer-to-peer network, they will observe, they will notice that this person is doing something fake, and they will evict you, right? So that's how the immutability works. That is how hash works. Consensus, we spoke about peer-to-peer networks, and we spoke about client nodes and how you need to install Ethereum and all them different softwares in the system and make it open, for the network to download all the data, that's the previous blocks and history of where money has gone to. Download all the data on your system, right? Mining, you have downloaded all the data, and then you are now verifying new data coming in. All of these things is how a blockchain network will work, right? You would need to understand this because as a blockchain developer, writing code is one thing or the other. The typical blockchain development is you write a smart contract, you kind of publish it the same way that you would publish and hash your transaction. You will publish it in a transaction and say, this is a smart contract, and anybody. And when you publish a smart contract in a transaction, it will create a public key for that smart contract, which anybody that accesses that public key will be able to. I don't know if your transaction helps people to count money, they will count their money. If your transaction helps people to mint NFTs, you're able to mint NFTs. If your transaction helps people to, I don't know, see other people that have visited your transaction. If your transaction helps people to hold their token in case of future. Different smart contracts do so many different things, right? And yeah, that's how it works, and that's what you would be doing as a developer. Yeah, and I feel like I am done with the theory part. I hope we all understood. And please now open for questions because I hate talking to myself. I like interaction. So yeah, that's it for me. Success. Then basically I would like questions. So anyone has questions, can you either put up our hands or type it in the question. Heritage.
Yes, ma'am.
Economic.
Yes, ma'am. How can
How can you what? I can't hear you.
I get the recording because I'm not able to meet up with the time.
You say?
I can't get the recording of this class.
Hello, Adeyemo. We are going to have the recording on YouTube. So you have access to it after 24 to 48 hours. You'll be contacted via mail and the link will be sent to you to watch a replay. So, yes, there will be a recorded session of this training. Thank you very much for your question. Mm.
Richard says, how did I learn all this? Honestly, it's from practice mostly. I was working with a mentor of mine. She gave me work that was blockchain. Since then, I started reading into it and doing more practical stuff. And the more all of this information are out there, they're just very hard to filter. But the more you look at it, the more you work with it, the more it makes sense. So I guess that's the journey. I can recommend a book. I can recommend a book. I can even recommend some articles. I'll get you, Richard. Um, Other hands are up. Who is next? No other hand. Wow. Wow, it's like everybody understood what I was saying today. Uh, Great. I'm impressed with myself and with you guys.
I don't know if Success is trying to say something, but I don't think I can hear him. But I can see that
Okay.
your mic is on.
Yeah, it's from started. Yeah, we can hear you, but it's faint. You're sounding far.
It's okay. We
Yeah.
can't hear Success for now. I don't know.
So
Is
really,
there
we all just understood.
is there any more questions from anyone? Well, in the absence of any question, I guess we'll have to call it a day then. Thank you very much, Ada, for this lovely and very informative session. Francis is saying thanks. And yeah.
Well, I can. Ah,
Oh,
thank
okay.
God.
Okon
Okoni.
Emmanuel has raised his
Yes.
hand, so please you can unmute yourself
I don't
and
think I can
ask a
escape
question.
somehow. I feel like Okoni Emmanuel, you can unmute. Yeah, hi, Okon. So, you say? You sound
It's talking
far.
about
I
encryption.
can't.
We can't hear you. If you can just put in your message on the chat box so Ada can be able to answer your question, that would be
Yeah.
better.
Oh, my God. Okay. Lawson, right? Ngole. I hope I pronounced it okay.
Yeah, can you hear me?
Yes, I can hear you.
All right, awesome. Thank you so much for the lecture. Um, my question goes thus: since we were talking about mining, I've been reading articles online and I'm seeing proof of work, proof of stake. So how does it come into play in all of that?
Okay. Well, since we have a bit more time, we can go into it a bit. I didn't want to go in depth because Samuel in our next class is going to go in depth, but let me just still give a surface definition. So, proof of work and proof of stake basically is the very popular way of validating data is the encryption comes in, or the hash of your transaction comes into the network, and then it has a lot of encryptions and decryptions and a lot of math things that you need to solve to get the real data, right? And then once you solve it and the equation is good, you say, okay, this is a valid block, and you put it and you say, okay, guys, can we all confirm it's a valid block, then we can add it, right? That's proof of work. Proof of work. So it all depends on the network, on the type of network. So Ethereum used to be proof of work, and initial Satoshi Nakamoto guy, his actual Bitcoin, the first one, was proof of work. Basically, anything that you're encrypting, the math and encryption, any transaction you're sending, the math and encryptions on that transaction, for for someone to use it on that chain, they would decrypt and calculate and calculate. So it was very compute computing heavy, and if you don't have RAM or you can't be a miner, right? Proof of stake is different, being that a lot of people saw, oh, if there are so many computers systems running and everything, it's not good for the environment, it's consuming power and such. But proof of stake means, as a miner now, I have a lot of Ethereum. So as a miner, you have to have a certain bank of Ethereum. Maybe I don't know how much in actual figures, for you to be a, like, because there are also different grades of proof of stake mining. There are also different grades. So yeah. So but I don't know the exact figure, but you have to have a solid amount of Ethereum, maybe a million. So I don't know if it's a million. Just assume it's like maybe 100 E or 30. Someone says 32 E. Thank you, Samuel. Bless your heart. But someone says 32 E. So you have to have that amount stored. You have to basically stake it. You are not removing it. You are not buying anything. It is there, such that the encryptions, right, on different, what do you call it, new transactions coming in, might not be that much, right? But you yourself, that you are mining the data, because Ethereum is holding your money, if you don't verify properly, or if you bring in any bad data in the network, your money is gone. You know what I'm saying? So um, it's a way of validating the data for the miners now. So they are incentivized not to do anything nonsense on the network. You have to just follow the protocol and follow the steps and make sure that the data is valid. Because if it's not valid, your money could be at stake. Okay. So it's a way of reducing a lot of the calculations required. This is me being very abstract and being very at the surface level. Someone will get into this from tomorrow, but it's a way of validating data without being too um, math or computer processing intensive, if that makes sense. So there are different types of ways. Yeah. So,
Right, thanks. That's fair.
you're welcome, Austin. Emmanuel Chukwu, you're next.
Yeah, thanks so much. Talking about the mining, you made mention of having up to 32 ETH, and also is it that they have a specific, yes, in our previous class we made mention of having a specific laptop or computers to use. Is there any other like devices, or because we have been hearing during when Elon Musk made a tweet about energy consumption and blah blah blah, that in fact it's like they are consuming energy. Is there any other external kind of devices that you must have to connect to your PC that just be doing the mining? I mean, because anytime I just hear mining, I just think about oil and gas. Is that like a big stuff like that, or is
I
there?
mean,
Yeah.
for proof of work, which Ethereum used to be proof of work, just recently they are moving to full proof of stake. But for proof of work, you generally have to have. They will tell you the specifications. So for you to volunteer your system to be a miner, they will tell you these are the specs. So RAM, so processing, so that, so that, so that, right? And say so storage, and you have to have excess of so storage too. You know, a lot popularly you find GPUs. So there are CPUs normally that are used to say CPUs attached to computer, but GPUs are what people like AWS use for their cloud functions. People like Google and the rest servers, basically. You see them. They're usually not. They usually look like small boxes, but their processing speed is mad. They're just for processing. So usually miners at the time that are used to proof of work. So they either buy, and they are expensive. Oh. If you see their processing speed and you see the price, you're like, wow. So people buy those things as a way to, how people, you can add RAM to your laptop now, as a way to add RAM to their system or something, because the more processing speed you have, the more you'll be able to mine, and the more money you'll be able to get in in very abstract concepts. So that's how it used to be, and it still is for a lot of for Bitcoin and some other blockchain networks, and some Ethereum classic people that have not merged yet. Not Ethereum classic. Ethereum, the ones that have not merged, they have not done the merge and pivoted to the new thing. They are still using um, systems with high processing stuff. So
Okay, thank you.
okay, and that's it for the questions.
Thank
Oh,
you for your question. Thank you so much for an amazing answer, Ada. Okon Emmanuel was trying to ask a question earlier. His question is: you talked about encryption on the blockchain. When does the encryption happen? During mining or after mining? And what triggers the encryption? Does the encryption happen after validation or as a part of the validation? So, over to you.
okay, these are good questions actually. So before you create, when you're creating a transaction block, you have to sign the transaction block. Again, I explained that our Ethereum address, our wallet addresses are generally public keys for our general public keys that show, okay, you can read and see that this wallet has so money inside, right? This is the very high level way of saying it. So yeah, so they are public keys. So creating a wallet in itself to join the network, you yourself have some encryption keys. You have your private keys. To create a transaction, you have to have a wallet address to create a transaction. To have that wallet address, you have your private key. So before you even create that transaction itself, you would have to encrypt it with your wallet address, private keys, and so yeah, you have to sign it. That's the word. You have to sign it. When you are signing it, is a form of encryption and authenticating it, basically saying I am the one that did it. Again, you have my public key, so you can read that I'm the one, but you can't sign it like I would, because I have my 12 private keys, right? So you will sign it before you put it into the transaction, into the pool for the miners to mine. The miners, they will take it, they would read it with your public key, your address, and for you to sign itself, there are some encryption stuff that has to go on, blockchain kind of cryptography type things. So they would decrypt it. They would be like, okay, this is valid. This is this guy that sent it. Oh, this is nice. And then they would, um, I would say they would encrypt it again and put it back into the network. But they will decrypt it and they'll put it back into the network. And the network in itself, when you get into the network, the previous chain, the previous block when it's joining the network, will have to be encrypted into this new block, like I showed you in that thing. So encryption is almost, as you are creating it, you are encrypting it. As they are validating it, they are decrypting it and they are checking different things. As they are adding it to the blockchain, there's also encryption being done. As other people are trying to validate what is going on, or if you are interacting with a smart contract, for example, you are signing a transaction, they have decrypted it, say, oh, it's going here, and it goes to this smart contract. The smart contract will decrypt it, some will encrypt it again and do something with it, something different, depending on what the smart contract is actually doing. So encryption is basically it's a core part of the blockchain process. It's the core part of the entire process. When it comes to the creation, the validation, and more importantly, the adding to the ledger, to the chain. So I hope that answers your question. Okon.
Um, Hi, Mr. Okon Emmanuel. I don't know if you can hear me, but if you are satisfied, you can just message us back on the chat box so we can
Yeah,
carry on the
he said yes.
conversation.
Leads me to another question. What's your other question? You can type it so since your audio is not.
He's asking when we're going to start practical sessions.
So we are going to have some more theoretical sessions. So we haven't really started talking about Ethereum itself, which is the whole smart contract thing. So that's the classes for this week. And then when we have that foundational understanding, when our brain gets why this is doing this, why we are writing such and such code, then we start writing such and such code. The practical session fully, I'm thinking, would maybe start from Friday or Monday. I'm not sure, depending on the case.
All right. Say I create a transaction, how will I get the last hash? And if I do get the last hash, but another transaction gets verified before mine, will the last hash change? So
So all of that, the timing of the verification, and that's a good question. The timing of the verification of different blocks matter to how they are being added to the blockchain. So the good thing about the blockchain network is that everything is online. Everything is public. So you can literally see the last block. You can literally see the last transactions. You can see some of the you can see some of the keys in there, and you can read some of the details, right? And you can see the last blocks. But only the miner adding the data to the network would be, they are the only ones that are in charge of the order in which it's being added. So it depends on when they mine your own and when they add it to the network. So the hash will not, the last hash will, the hash of your encryption, it will not matter so long as it is a valid transaction and is sent and there's a valid interval of time for processing, right? It really does not matter the order until it gets, well, the order matters technically. The order matters, but how will I put it? You really, the it will not invalidate the transaction per se, right? It matters, but your transaction will still be valid and will still be added to the blockchain, right? So it will not be an invalid transaction because you put it at social time and somebody mined something before your own. No, it will still be a valid if it's in a time interval and all of that, which are part of some of the foundational things in every blockchain virtual machine. Basically, they have all these parameter sets. But once it has been added, that's the only time that the previous hash would invalidate the data. I hope that makes sense. Yeah.
he's
So it
asking,
says,
so my transaction can be created within nonce but can be validated with a different nonce.
miners generally miners generally have to have their own nonce. But to be honest, actually, yes, they are validated by the miners. But It's not how do you put it? It's all part of like the EVM ecosystem per se. So there has to be a miner mining it with their own nodes. So yes, technically, but someone else that is not a miner or have all the system requirements set up and software set up cannot just validate your transaction with their own nodes. You get they have no um, they shouldn't be able to or they cannot. But if you are a miner, you have downloaded all the things, you have installed all the things, you have EVM um, client node running and everything is good, then your nonce can be used to validate other people's nodes. So yes, which is a way to incentivize miners because technically they can order if a miner mines a block, they can put it in front of other people's block. It is their mining. So long as the mining is valid, it is their mining. So
We have another question from Aliyu Bashir. Does a notification pop up for a miner when a transaction is being created?
I mean technically it's not like a user interface where something will pop up. But if you if you can ping the Ethereum network, right, and you see all the transactions coming in. So it's I don't think they have good graphic user interface. You say, oh, pop up, you can click to mine. No, the miners generally have applications running that
Mm.
are connected to the network and all the transactions come in and they pick. But technically, with their application running, I decided to put like they're all writing code. We all know how to write code. They can decide if wallet address is signed by me, manifest, if they want. So there is no notification that pops up, but every miner can see all the transactions coming in. And yeah, so yeah, I leave
Interesting.
over for the question.
Thank you so
Okay.
much for your answer. This was a very interactive session. It was great. I learned a lot, and I'm very sure we all did too here on this meeting. So, if there's any more questions, you can drop it on the chat box, and if there isn't, then we would wrap it up and call it a day. Thank you so much, Ada, for a great session, and we'll be meeting on Tuesday by 7 p.m. same time. Thank you all so much for joining in. Have a great night. Yes, the video is recorded. It's going to be posted on YouTube, and everyone is going to have access to the link. It's going to be emailed to you, and we'll also send you the link on the group chat on Discord and WhatsApp. So, yes, we have classes Mondays, Wednesdays, and Friday. So, um, same time, 7 p.m. Mr. Taiwo Sunday, Mondays, Wednesdays, and Fridays, 7 p.m. So, thank you everyone for joining in. Yes, of course, this was such a great class. Thank you so much, Ada. Um, all right, bye everyone.
All right, bye everyone.
Bye, everyone.